My talk is called Our Search Has an Elastic Heart, and my name is Terry. I will be presenting to you today, so thank you for coming. I did name this talk, if anyone else is a Sia fan, love her, so that was one of her songs that I thought was really cute to be able to fit it into my presentation. So, a little bit about me. I am from Florida. I moved here many years ago to go to Georgia Tech. Once I got out of Georgia Tech, I entered into what I consider to be the wild, wild world of quality assurance testing. My specialty was performance, load, and stress testing against large software systems. I spent a good bit of time in that field before I decided to go to the Iron Yard, which is one of the boot camps that's local to Atlanta, and join the dark side of development. I've been working as a back-end developer since 2015, and right now I'm working for HireWire, which is a local Atlanta startup that does on-demand hiring for retail and service industry jobs. So very excited to be able to be here. Now, why did I choose to talk about Elasticsearch? And I kind of like internet memes, so there's just only one. I didn't want to over meme my talk. When I started working at HireWire, everyone used to complain that their search was really slow. And you ask what is really slow? Well, it was on average 9 seconds in production. And if you try to sit here and hold your phone out in front of your face and count to 9 seconds and think, well, I actually wait for whatever's happening to happen, nobody's gonna wait for that. I don't. I'm no, I'll come back later, be able to be faster. But it wasn't. So my manager asked me to look into using Elasticsearch to try to see if we can speed it up. The original code was using a stored procedure in SQL, and that was the cause behind a lot of the slowness, so we decided to give Elasticsearch a try. It's something that I really enjoyed coming to work with, but I could not find a lot of info on how to get it set up the way that we needed to use it at HireWire, so I thought, well, hey, let me try to give a talk and demystify it a little bit for people so that maybe they'll feel comfortable trying it out for themselves. So what we're going to cover today, we're going to try to cover a good bit of ground, and I've saved some time at the end for questions. We're going to start with the lingo because developers like having buzzwords and stuff, so kind of need to know a little bit about what some of the terminology means. But we're not going to hang out there very long. We'll move right into setting up Elasticsearch in your local dev environment. I work in Ruby on Rails. There will be some Rails code and that I will be displaying. I'm going to try really hard to walk through all of it so that it's something that anyone can look at. And again, my presentation will be available afterwards. From setup, we'll move into creating our index and adding document information to it, as well as loading our data up. And then what I like to call converting SQL to Elasticsearch queries, because that is essentially what I ended up having to do at HireWire. The stored procedure we had, I swear it was this long on my screen, so when I had to make that into an Elasticsearch query, I ran into a lot of problems, and the methodology I'm going to show you is how I ended up converting it over. And lastly, we'll just do some recap of what we talked about, and then some tips based on my experiences that I thought would be helpful for you. So on to the lingo, everyone's favorite thing. If you don't know what Elasticsearch is a highly scalable text search and analytics engine, and allows you to store and search large volumes of data. All of the communication that takes place with Elasticsearch is done through JSON format, so that should be really familiar to anyone that works in Rails and probably other web technologies. Once you're inside the Elasticsearch ecosystem, you start out with something that they call a cluster, and a cluster is just the collection of your Elasticsearch servers. And in the Elasticsearch world, their servers are called nodes. So honestly, if you don't remember that, you can still totally get Elasticsearch working. I had no idea what these terms meant, and I got it installed and running. Totally fine. The two key pieces of information that you need to know is what an index is and what a document is. An index is a collection of documents that have special character or similar characteristics. So I like to think of the comparison to SQL as an index is more of a database almost, and you can tell it to store different types of documents, and in my mind, I equate that to like tables, because tables generally have information that's closely related to each other. So that's the way that I would try to think of it if you're coming from something that is maybe different from Elasticsearch, is that you have almost like a collection of tables, and then your documents, which don't live in a table, but essentially like they're all the same type, so they're technically stored very in a similar area. The documents are your good stuff. That's where you have all of the information that you want to search. So on to setup, because nobody really wants to talk about terms. Setting up for me and Rails was the initial installation I thought was pretty easy. I highly recommend using Homebrew if you're on a Mac to get it installed. That's what I'm recommending here. And you do have to have Java 1.8 or above. I would also recommend that you use at least 5.3 or 5.4 Elasticsearch, that version. Part of the reason why I'm recommending specific versions is the language or the syntax in Elasticsearch did change considerably between some of the older versions, like the 1 and the 2 version. So it's important that if you want to get Elasticsearch, that I would try to recommend using the more later versions. And also be really careful if you're searching on Stack Overflow to look at the date. I mean, if you look online, you know sometimes the old stuff's not right. I ran into a lot of that when I was developing. The install, you would just run brew install Elasticsearch. I believe it gives you 5.4 from Homebrew. And then when you want to run it, you just run Elasticsearch from your command line, and it starts right up. It was actually like the least painful part of this entire process for me. So you can have Elasticsearch run in the background, but as a developer, I would prefer to see the logs running real time, so I would recommend at least starting with it running in the foreground so that you can see the logs. Now that we have it set up on our development environment, the next step is getting it prepped to be in Rails. So Rails uses gem files to pull in different code that you want to use in your app. And there's 3 gems that I'm recommending you're using. And I'll talk about the third one in a second. So the top 2 are just Elasticsearch-model and Elasticsearch-Rails. These are the 2 gems that we used at HireWire to get everything up and running. And the only note that I have in here, and they were pretty specific about this, is that if you use pagination gems like Kaminari, you want to make sure that the gem is added above Elasticsearch in the order so that the Kaminari gem is loaded before the Elasticsearch ones. I don't know why they did that, but I would just follow their instructions, because otherwise you may get some funny results from your paging stuff. The third gem is actually not written by Elasticsearch, but at HireWire we ran ES, and I'll just do ES because I'm just saying Elasticsearch way too much. So we ran ES in Amazon, and I ran into a lot of problems trying to get it to connect properly to our instance in Amazon. This is the gem that you would need to authenticate properly with AWS credentials, and I'm going to put that in my talk, or I put that in my talk because I felt there was not really one place where all of this information was, and I thought it would be nice to at least give it to you. If you decide to run your instance in Amazon, you will need to send the authentication information along with your request, and this is the gem to do it. So not a requirement unless you're in AWS. So after you have your gem file done, you then need to set up the configuration to allow Rails to talk to ES. I put this in a file called elastic_search, and I threw it in this folder structure. If yours is different, that's fine too. I just always like when people tell me where things live, so this is where this lived for me. The config is pretty static, or you'll see this probably across a lot of help files. I did put my host name, which is the URL that you're going to be connecting to, in an environment variable. But I also put, if you're just doing it on localhost, this is the URL where Elasticsearch should be running unless you've chosen some other port when you start Elasticsearch up. It defaults to 9200. The transport option stuff I just left in there. And then there's some additional reload configurations you can give it. If you want to leave these in here, if you don't, it's fine. I put some comments about what each of those does, but it's not really important for this talk. But I did want to give you like a full working config file. The second part, or the last part down here, is just a logging setting. And I would recommend turning logging on, but only if you're in your development environment and not running rake tasks. And we'll go over a little bit about this second part later. But you definitely want logs for development. You don't want them running in production. There's a lot of logs. So I did say there was some differences when you're connecting to Amazon. So there are some considerations. You need to have your access key and secret key from AWS, as well as the region and the service name, which in AWS I think it's called ES. Pretty easy to remember. And ours lived in the US East 1 region. So I wanted to at least give y'all a full config. This was our full production config that includes the connection piece that you will need for Amazon. What that does include is basically in every request, if I'm in production, because my other environments weren't there, I'm sending across the what AWS requires for you to be allowed to connect to it. If you're not using Amazon, just don't use that part. All right, got it set up, we've got Rails running. Now what? We need an index and we need documents in it. So we're gonna be creating an index, well, or at least telling Rails to create an index and what's in it, our documents. So the two includes, or where you do this is in your model file. I would say if you look at some of the examples, may not tell you to do things directly in the model file. They may have an include file that they write that gets included all over the place. This is what I'm recommending when you're learning, because this is the simplest implementation that you can get. And we're going to use models that are close to what we have at HireWire, and I will explain what the data pieces are that we're going to be talking about in a second. At the top of the model file, you would include these two Elasticsearch provide modules, and they give you two sets of features that I cared about, which basically the model class gives you access to a search method where you can send queries in to your index. And then get .records on the end of that will give you the database records like you normally would get if you queried the database. Which this I thought was great because it's really readable, which is super Ruby, and very close to like what a database call would get you. I did put a note in here that, oh sorry, before that, the callbacks piece, what that gives you is Rails lets you have something called like hooks that after you update, delete, or add things to your database, these methods will run. And what this callbacks thing does is it will automatically update the index when you change your data, so you don't have to do it. People do recommend not doing this piece and doing custom callbacks, and there's some kind of reasoning behind that, which is if you are indexing things that are not stored in your model directly, like maybe you have a calculated field, like an average or something that you calculate on the fly, but you don't store it, and you want to index that average, maybe you're doing like a ratings app or something. These callbacks may not update Elasticsearch the way that you think that they will, so just be pretty careful if you are having problems with it and your index is not being updated. Try overriding the callbacks and writing them yourself. But I think just for the learning purposes, I would always start at the base. It's the best way. So now that we've told this model, yes, you can be indexed. You can talk to Elasticsearch. It has all the communication that we need due to these two includes. We then need to tell it what our index name and what our document type is going to be. So again, when I was at HireWire, I chose an index name that matched the model name. And in hindsight, that was not really what I would have done the second time around. So I would recommend picking just like a general index name. And for mine, I chose HireWire_index. I did add an environment at the front of it so that if you have a QA environment or a staging environment, you could switch easily to a different index based on which environment you want. If you do that now, it'll be way easier for you than deciding, trust me, after you're in production to change your index name. And the document type, I'm always just recommending using the model name because you're going to be storing data fields that are related to one another, and you're basically essentially duplicating stuff that's in your database about this person data into the index, and so that's what I would recommend for their document type. So the next part, after you said, okay, I have my index name, that's who I'm going to talk to, I'm storing data about this document type, which is a person, you need to tell it what fields from your model you want to store. I'll tell you a little bit about what these fields mean because I think it'll be a little bit more helpful. So at HireWire we do on-demand hiring and we have people looking for jobs. So we allow them to make themselves like discoverable or not. Maybe you're not looking for a job right now. We ask them how far they want to travel for work, which if you're from Atlanta, that is very important. Maybe you don't want to travel 40 miles for work because that would super suck. We store where they are. So we have a geopoint type, which I'll show you what that looks like in a second, but storing their location was like super, I thought that was super cool, because you can basically map out where people are and then where the jobs are and kind of help hook them up together because they're in the right proximity. We also ask them what they're interested in working in, because I don't want to show you a job for a bartender if you don't want to be a bartender. That's really not, that's not great for the app to do. So we ask you what you're looking for. And then we also do store some information about like when you last signed in, because if you haven't been in the app for a while and maybe don't want to try to keep hooking you up with jobs if you're really not using the app. So we do have some information that allows us to show like more active people. Now that we've gone through this, this is basically like what fields you want to add to the index. And for the purposes of this talk, these are the fields that I chose to add. The only other piece of information you have to know is the name of the field and the type. There are many more types than this, but I'm not really focusing on types in this talk, so the Elasticsearch documentation has a lot more information on what types are available, and this will be available after if you want to look at it. Now that we have told the person model we want to index it, we have the settings of what's being indexed, we actually have to give ES a way to pull the data out of our database so that Elasticsearch can have it loaded in. And the way that you do that is there's a method that you're required to put, it's called asIndexedJSON. That method needs to return back all of your indexed data in JSON format. So it's like, nice, asIndexedJSON, very descriptive. This is an example of how to write that. Your asIndexedJSON may not be this complicated, or it may be more complicated, but essentially I'm building up everything that we had in this slide. All of this data needs to be returned in JSON in the exact same format. So I'm using some Rails code here, but I think what would be more important is to see what this method actually returns back so you can get a better idea of what the JSON looks like as it's sent to Elasticsearch. So this is an example of what that method would put out. And I would highly recommend, if you are writing that method, to test it before you try to load your data to ES. Trust me, I used to be a tester. Testing is great. People will lie to you, tell you don't test things as a developer. They're lying to you. Testing is great. You should test this method. So now I'm getting off my testing soapbox. This is an example of what the data would look like, and each piece of data would definitely be different. I do leave the ID in there because I think that that was required to be able to pull the records out of the database with that records call. So that's the only piece of data that would be in here extra that wasn't kind of called out before. We also have this location field, so if you're doing geopoints, you do have to have the lat-longitude of your data, and then you would kind of nestle it into a location like I have here. We also have the user one that kind of is nested in like that, and I just have that so I can use it for an example search type later. Okay, I'm doing okay on time. So now that we have our model set, we're ready to go. Now I'm like, okay, how do we get data into the ES box? Like, I had no idea. For that, the GEM documentation, I as well recommend writing a rake task because you can easily run it and kind of let it go and finish its work. If you have a lot of data, it can take a long time. We had over 100,000 pieces of data to add in at least one of the in document types that we had, and it took a while. So rake tasks are like definitely the way to go. I'm going to show you what the rake task looks like. Now I know there's a good bit of code on here, so we'll just walk through it step by step. The first thing that you want to do is grab an Elasticsearch client. This will allow you to communicate with the Elasticsearch server. So the only thing you really need to give it here is the host name, which I have an environment variable because I thought ahead. And then, again, I have the AWS code in here just to keep with that theme. If you have Amazon, this will also need to be in this rig task so you can communicate with AWS. We have an index name that I've chosen, which you can access the index name that you provided in the model document, in the model by doing .index_name on class name, but I also added a secure random hex at the end, and the reason why I did that is when you add data to Elasticsearch the first time, it's great. You add it to a blank index and everything's great and happy, but if you ever have to update your Elasticsearch data, if you have to delete your index and recreate it, all of your users would have a lot of downtime. So if you imagine you're trying to find a job on HireWire and then all of a sudden like search doesn't work for 9 hours because I accidentally deleted the index and we had to recreate it, that would be super bad. So I'm recommending that you put like some sort of random number at the end of this because we are going to use an alias to connect to ES. The alias will allow us to easily switch things out, and that's something I'm going to talk about at the end with my tips. I'm just recommending this now. If you use this feature and you never have to refresh your index data at all, then you'll be fine. But if you were me like 4 months ago and you had to do it and you chose to not use a random data at the end, you're going to have really bad time in production and maybe have some downtime. It's not good. So the last pieces of this is us actually creating the index. We give it the index name, and then we have to tell it the settings and the mappings. So the settings and the mappings are actually back from here. We have our settings and our mappings. So all that's doing is pulling that information from our model file that we already set up. So I apologize for not kind of explaining that a little bit better before, but that's where that data is pulling from. And finally, I'm adding my alias because I have 2020, or not 2020, the hindsight. My hindsight is 2020. And in my future ES stuff, I would definitely do the import this way. The last 2 lines is me grabbing all of the data that I want to add and then running an import method. The import method is provided by Elasticsearch Gem, and it may take a while if you have a lot of data. It just is slow. So maybe don't set it to go off at like Friday if you want to go home after work. And also, you don't need to get all the data. If there's only some data that you want to add, you can do that. Okay. So on to the fun. Oh yeah, that's my dog. She's super cute. She likes to bite people, so it's fine. This is the part that I was super excited about this talk, and I'm going to try to make sure we hit all the points. I had a really hard time taking a giant query that was like 70 lines long and converting that into Elasticsearch syntax. So what I ended up doing was taking each chunk of it and making small little methods that made more sense to me because I was trying to learn the syntax and also trying to figure out what the heck this query was doing. So what I'm going to show you is 4 different types of Elasticsearch searches and how they would look in SQL and then what it would look like when you do it in ES. The first one is a term search. The term search is very similar to, I equate it to something like a like. If we have people that are looking for interested positions where they're like have server in them, then we want to show them server positions. The Elasticsearch syntax always starts with an outside bracket with a query key, and then you feed the different queries in. So for this one, the key is going to be term. You give it the field that you're looking at, which is positions interested in, and you give it a piece of text that it's looking for. It's really not that bad, I promise. Then you run that search method that I talked to you about earlier and ask for the records, and that would return back all those records for you. This is definitely one that I use a good bit, and I would recommend you use it too. The next one is called a range search. So maybe we're looking for something we're using less than or equal to or between or greater than. That would convert down to what Elasticsearch calls a range query. Again, we have that range key on the outside. You tell it what field you're looking at, and then you tell it what you're kind of trying to do. So your LTE is less than or equal to, GTE is another option. There are more options here, but we're not really going to go into that during this talk. And then you would, again, same thing, we'll run the query on our person model and get the records back. I use this one a lot. It's not just numbers, you can also use it on dates, which is pretty cool, so it works very similar to what you would see in a SQL statement. Next, we have my favorite. I'm like obsessed with geodistance searches right now. The SQL is horrible. I haven't seen the sine and cosine signal since sine and cosine since college, and that was a while ago. So this was bad. I didn't want to read that. I thought it was really neat how it was super readable to figure out what this query was doing. The only thing with the geodistance search is it's not really a query in Elasticsearch land. They use it as a filter. And to me, they really feel the same, but in Elasticsearch, essentially what it does is it gets you all of the data and then applies a filter to it and throws out things that don't match the filter. Honestly, I don't know what the difference is, but if you're doing a geodistance search, you're going to apply it as a filter. You have a geodistance outer key, and then you're going to give it 3 different things. How far the person is you're looking for, how far you're looking out, what kind of distance type you're going to use, and I just left it as default for sloppy arc because we weren't looking to be super precise, just mostly precise. And then that location, lat longitude, which matches what's in our Elasticsearch document. The only thing I would note is if you live somewhere where kilometers are king, then you can switch over to KM pretty easily. The query that I wrote down here has a different query. It's called a bool. We're going to go over that in a second, so just ignore that part. The important part is that the filter has been applied. We're getting all the data and then applying our distance filter to it. And I sent in my lat, longitude, and distance to that method. So, all right, lastly, we're doing nested searches. And I feel like this one, I just wanted to show it to you. If I had gone back and redone my ES index, I probably wouldn't have nested this particular piece of data, but it's an important search to have. Nested, I looked at it as almost like a join query. So you're joining the users table where the user has been signed in at least 21 days or closer to 21 days ago or newer, I guess. For the nested query, you again, inside your query, you give it a nested key, and then you tell it the path. So the path's almost like your join table. So my join table here is users, and then I give that nested path another query, which is a range query, which we already kind of talked about, which does a greater than or equal to now minus 21 days. It's pretty similar to the SQL, but it's a lot easier when you read it. One thing I will say about Elasticsearch is they're really into adding queries that go in, so sometimes things will kind of nest in very far. If you chunk things up like this, it becomes a lot easier to understand and read, so just don't get overwhelmed if you see stuff on Stack Overflow that's crazy looking. All right, so we got the nested query done. So now you're okay, how are these tiny queries? This is great, this is like a tutorial, but how do I get it all into Rails together? To get it all into Rails together, I use something called a bool query. I use it as a base for everything that I did. There's 5 different things that you can use in here. You have a must, which is very similar to an and in SQL. A must not, which you can use to say don't give me these things back, so that's your not. Your or, which is kind of like an or your should, which is kind of like an or, but then you also can give this minimum should match field, and you can make it more than one. So you can say, you kind of have to meet these requirements, but you only have to meet 4 of them for me to get the data back. And finally, your filter, which I would use for geodistance. This is the best thing ever. If you understand any Elasticsearch stuff, I would definitely make sure you read up on this one, because this is how I was able to turn a giant query into a giant SQL query into Elasticsearch query. And that is how I tied it together. So I've been showing you methods before on purpose, because this is essentially this is what my code looked like in production. It's not the exact code, but I'm very systematic. I think it's my QA brain, where I like to chunk things down into something that makes more sense to me. and then use it to build things up. So that if somebody ever comes into the code, they can be like, oh, these are all the things that we're querying on without actually having to understand what Elasticsearch syntax looks like. So this is how I chose to tie it all together. We have our query that we start here, and because these are arrays, you can add things to them. So you can have more than one must. You can have more than one must not. And you can have more than one filter if you want. And once you run this, this would pretty much tie all of those queries together into one big one. I thought this was the most powerful piece of information for getting ES working, and you don't have to start big. Please don't start big, start small. It's much easier. So I know I'm on the end of my talk, so I'm almost done. So we have our recap. I would start with one model. Don't go crazy. I also found out that storing stuff in Amazon and ES is very expensive. So only index what you need. Don't index the world. If you're not querying it, you can drop it. I'm recommending you pick a unique index name, but also use an alias to attach to it. And the reason why is it will allow you to refresh your Elasticsearch data without having downtime for your users. And lastly, I would recommend that you break your queries up. So where we ended up at HireWire is we started with 9 seconds for response time. And when I was done my Elasticsearch work, we were at 500 milliseconds. And I was super proud of that because I was like, this is so much better. And I think our users were happier. I mean, they had to have been. It was like so slow. So I was really excited to use this tech, and hopefully you all get to use it soon. I don't have time to cover these additional slides, but I do have some info on why you would want to refresh your data, or like how you can do it. And I have the reference, the article that I used to figure out how to do it myself. They were the ones that recommended using the alias. We also used a combination of RigTest and Redis, which is a caching system that is used. It gets used at every job I've had so far. And lastly, I have information on how to install Elasticsearch Head, which is a web. It's like a web client you can use to talk to Elasticsearch, so you don't have to go through Rails. If you're just working on learning Elasticsearch and you don't want to learn Rails, or you don't know Rails, you can use this to build queries out, and you can use that to figure out like how ES works. There's like one more config that you have to do, which I don't have time to do, but this is what it looks like. And when you're connected to your instance of Elasticsearch, it's green, very easy. So this will be available after my slides, and I think that is it. I'm at 32 minutes, so I would just like to say thank you from me and Allie, Alligator, my dog. I have Twitter, and I have a website, which has some stuff on it. It's pretty cool, but thank you so much for coming. I really appreciate it.